So number 3 says, what equations represent the asymptote for this graph? Now, if you remember an asymptote, it's kind of like a line that divides the graph. Typically is the way a lot of students think about it. It'll separate it, but the truth is, what that means is this graph will approach some value. So there are multiple types of asymptotes we've learned about this year. We've learned about vertical asymptotes, when a graph is undefined. We've learned about horizontal asymptotes, and we've learned about slanted asymptotes. And they come from a couple rules. The first rule for a vertical asymptote is you cannot divide by 0. Do you remember that? You can't divide by 0 idea? So wherever this denominator equals 0, wherever this equals 0, there's going to be a vertical asymptote. Whenever the denominator equals 0, there will be a vertical asymptote. Again, we could graph this and look, but I'm going to start with the algebra. So if I wanted to solve this, this is a trinomial. Remember 3 pieces? We had a technique for that. What technique did we use? I taught you this the very first day of the school year, actually. X method, yeah. Where we go, anything that's in the form of a trinomial, ax squared plus bx plus c, what we do is we set up an x, and we do the values of a times c in the top of the x, the value of b down below, and we look for 2 numbers, which I called m and n the very first day of the school year, that multiply to be the top, but add to be the bottom. So in our case, the a is 1, the c is -6. So it's a, b, c. That means my b is -5. So we're looking for 2 numbers that multiply to be -6, add to be -5. Ooh, you're quick. And so also what I did the first day of school is I wrote down this chart, and I just wrote all the factors of 6. I do the multiplying. It's a lot easier if you find the factor. So there's 1 and 6, and there's 2 and 3. I think those are the only ones. And so then you say, okay, which one has a combination of a 5? They both can give us 5. So which ones can give me a -5? Well, it's either -2 and -3 or +1 and -6. And so then you need to ask yourself, okay, which one would multiply to be a -6? Is it 1 times -6 or -2 times -3? Which one multiplies to be a -6? This top. So those are our values, 1 and -6, which means this whole equation could be rewritten. I'm not going to rewrite the top. I'm just going to leave it as 3x cubed minus 3x squared plus 8x minus 1. And on the bottom, I'll say it's x plus 1 and x minus 6. Now, what if one of these factors cancels with the factor in the top, then it would be a whole. But right now, I'm just going to assume, and we'll look at the picture in a second, that there's going to be 2 vertical asymptotes. You know what? I'm going to graph it first, just so we can see if our assumption's off or if it's correct. So I don't know how this factors, and it'll take longer to factor it. So I'm just going to look at the whole equation itself and see if we have vertical asymptotes or if it's, where's the division? There we go. If it's a whole. 3x cubed minus 3x squared plus 8x minus 1 plus 8x minus 1, and the denominator was x squared minus 5x minus 6. And so when I look at this, I'm going to zoom out. I can see that there are 2 vertical asymptotes. You see, there's 3 pieces of this graph, and the way a graph will break apart is either, if you remove, it's either a jump discontinuity, which comes from piecewise, a removable, which this is not removable. That's when it look on a graph, it looks like they're connected, but this one you can clearly see a separation, or it's infinite. So this does have 2 infinites, and so we found them. There are these 2 locations. So we have an infinite discontinuity, meaning a vertical asymptote. So we have vertical asymptotes at, let me do the at symbol, at x equals -1, because remember inside lies, you solve it, x equals -1 and x equals +6. So if I type that in this graph, whoops, wrong one. If I type this in, this should divide the graph perfectly. oh, well, let me copy this one, x equals 6. So these two graphs should divide. I'm going to do them dotted. And now zoom in. You see how this dotted line separates that graph perfectly? These two separates them. And over here, it also separates these pieces perfectly. So we did do that part right. Those are vertical asymptotes. Now I can see this also has what's called a slanted asymptote. If I zoom out, you see how it's looking like a slanted line? That means there's a slanted asymptote. And so coming back to our document, the way you find the horizontal or slanted is you can use the, there was the 3 words, botan, bobo, or eats DC, which talks about your exponents. Are these bigger, are the exponents bigger on top? Are they bigger on bottom, or are the exponents the same? Bigger on top. And what bigger on top stood for, the acronym was botan. So I'm going to draw a line here. For botan, what that meant is if it's bigger on top, there's no horizontal asymptote. Instead, it's slanted or oblique is another name. Slanted or oblique. Okay, and the way we found that is by division. So if you want to know what the exact answer is, you would divide these into one another. I'm going to use long division. It'll only take 2 steps, really a step and a half to get this. Joe, do you mind shutting that door for me? Okay, thank you. And so what you're doing is you're asking yourself, what do I need to multiply the first term to get this term? Because multiplying is the opposite of division. So instead of, or you could say, what is 3x cubed divided by x squared? What is 3x cubed divided by x squared? 3x. And so here's my slanted asymptote. It's going to be y equals the top. And so when I multiply everything here by 3x, so I'd have here 3x cubed. And then I multiply this one by 3x. Negative 15x squared. And then finally I multiply this one by negative 3x, which is negative 18x. The fundamental rule of division, do y'all remember it? We switch the signs all the way across. When you do long division, you have to switch the signs. So this drops out. This becomes a positive 12x squared, and this becomes a positive 26x, and then you drop the 1, the negative 1 rather. And so last step, because this is going to be the last time I can do this, is you ask yourself, what is 12x squared divided by x squared? What is 12x squared divided by x squared?
12x.
It would just be a 12. Just 12. It already has the x squares. And so I actually don't have to go any further. That's my answer. Because there can't be a smaller value. This says 1 power of x. This says no powers of x. We're done. So you could multiply that across if you wanted to. And you'd have 12x squared. That would be a negative 60. Negative 60x. And then this would be negative 72. And you would switch your signs or whatever. But this would just be the remainder. And you don't need the remainder for an asymptote. So that's why you don't have to do this part I'm doing here, but you would end up with 86x plus 71, which you can't see that at all. Let me write that below. 86x plus 71 is what you'd end up with as a remainder, which we called r of x earlier. You don't need a remainder here. This would be your slanted asymptote. So I'm going to go check the graphic, and then I'm going to tell you how to get this answer really fast if you run a test. 3x plus 12. Check that out. What do you notice about this purple line compared to the red?
The same.
They look exactly the same, don't they? Yep. So we got the right answer. Okay, so now let's just say you're taking a multiple choice test. Would I recommend you do this algebra? Heck no, that took so long. What would I recommend you do? Graph the actual problem and then type in the answer choices and see which one works. So I'm going to skip to the purple. You could zoom out real quickly and see that the purple is the same as the red. So that would work if it was asking, in the answer choices were for slanted asymptotes. If it were vertical asymptotes that the answer choices represented, when you put them in, you'd see that they would divide the equation, or maybe they don't divide the equations. Like this one, would this be a correct answer now? This blue, does it divide the graph perfectly? No. It divided the graph perfectly at -1, but it divides these two pieces at -1, but it did not divide it at, say, +1. At +1, it goes straight through the graph. It's not dividing the pieces apart. Okay, so that's, let me take that one off so you can see clearly. That's how you would do it if you were going to just use the calculator. Much easier again for the calculator. A lot of the ACP, let's be real, it's multiple choice, and most multiple choice questions go a lot quicker if you just use calculator correctly, just because you already know the answer choice, what values to test.